Hey there everyone, Ramesh here. Welcome to Spring Boot AWS deployment course. In this course, you are going to learn how to build Spring Boot REST APIs and how to deploy Spring Boot application on AWS Cloud. Well, let's take a look into what you will learn in this course. You will learn how to build CRUD REST APIs using Spring Boot. Then you will learn how to use Postman client to test REST APIs. And then you will learn how to use different AWS services such as AWS Relational Database Service, Elastic Beanstalk Service, S3 Service, etc. And you will learn how to deploy MySQL database on AWS Cloud. And finally, you will learn how to deploy Spring Boot application on AWS Cloud. Okay, so this is end-to-end course, how to build REST APIs using Spring Boot and how to deploy Spring Boot application on production, that is on AWS Cloud. Here is the development process. First, we will build CRUD REST APIs using Spring Boot step by step, line by line coding, and then we will host source code of this project on GitHub, and then we'll deploy this Spring Boot CRUD application on AWS Cloud. Okay, these are the high level steps. And here are the tools and technologies that we will be using in this course. We will use Java 8 Plus, and we use Spring Boot, and we use Spring Data JPA, which internally uses Hibernate as a JPA provider, and we are going to use MySQL database to store and retrieve the data, and we use Eclipse STS IDE to build our Spring Boot application, and then we use Postman client to test REST APIs. Next, we use AWS RDS service to deploy MySQL database on AWS Cloud, and then we use AWS Elastic Beanstalk service to deploy our Spring Boot CRUD application on AWS Cloud. Okay, great. Let's quickly take a look into Spring Boot overview. As we know that Spring Boot is a very popular framework for building REST web services and microservices. Spring Boot is an opinionated framework that helps developers to build Spring-based applications quickly and easily. The main goal of Spring Boot is to quickly create a Spring-based applications without requiring developers to write the same boilerplate configuration and again. Okay, Spring Boot has taken Spring framework to the next level. It has drastically reduced the configuration and setup time required for Spring-based projects. Actually, we can set up Spring project with almost zero configuration and start building things that actually matter to your application. And Spring Boot provides a lot of features that we can use to develop a production ready applications. So this is the high level architecture of our Spring Boot project. So client sends a HTTP request to the API layer or controller layer receives the request from the client, and request can be HTTP GET, POST, PUT and delete method. And we use Spring MVC framework to develop a controller layer. And this is the service layer. If you have business logic, then you can create a service layer and you can keep all your business logic inside a service layer. And this is the DAO layer, so you can keep all your database related stuff inside this DAO layer. So DAO layer is basically responsible to establish a connection with the underlying database, and it perform a CRUD database operations. Alright, so this is the typical architecture of our Spring Boot project, and we use Spring Data JPA to develop a persistence layer or a DAO layer, and Spring Data JPA internally uses Hibernate as a default JPA provider. Alright, and we are going to use MySQL database to store and retrieve the data, and we are going to use Postman REST client to test our REST endpoints. Alright, so this is a Spring Boot CRUD REST API design. So here, look at here, these are the 5 REST APIs we are going to develop: get users, post user, get user, put user and delete user. Without further ado, let's switch to the Eclipse STS IDE and let us start developing Spring Boot CRUD RESTful web services. I'm in Eclipse STS IDE. Let's go ahead and let's create and bootstrap Spring Boot project. Go to the file, new, and choose Spring Starter project. This is the Spring Initializer website which is integrated in Spring Toolsuite IDE, and we can use this Spring Initializer to quickly create and bootstrap our Spring Boot project. Alright, and give name as Spring Boot CRUD RESTful web services, and type as a Marvin, and packaging as a jar, and Java version 8, and language Java, and group ID as net.java guides. You can use any group ID that you want, and artifact as Spring Boot CRUD RESTful web services. So this is going to be our application name, and provide a version, keep default as it is, in description, and package net.java guides Spring Boot. You can give any package name that you want. Once you are happy with the details, click next, and keep Spring Boot version as it is, because Spring Boot team recommended this latest release of Spring Boot project. And here we are going to select a required Spring Boot starter dependencies for our Spring Boot project. So we are going to develop Spring Boot REST web services. For that, let's go ahead and let's pick up Spring Web Starter dependency, and we are going to develop a DAO layer or a persistence layer. For that, we are going to pick up Spring Data JPA dependency. Alright, and we are going to use MySQL database. So let's go ahead and let's pick up MySQL driver. So these are the three dependencies required to create our Spring Boot project. Alright, once you fill up all the details, then hit finish. So this will create a Spring Boot project with default project structure. Alright, great. Now if you look at the class here, so this is the main entry point of our Spring Boot project, and this class annotated with @Spring Boot application annotation. So this annotation is a combination of @configuration, @enable auto configuration, and @component scan annotation. Alright, now what we will do, we create a packaging structure. So let's go ahead and let's create a few packages. Right click new and give package name as entity. Alright, now let's go ahead and let's create one more package. Let's name it as controller, and let's go ahead and let's create one more package and name it as a repository. Alright, and let's go ahead and let's create one more package and name it as exception. Okay, great. So this is very simple Spring Boot CRUD REST web service application, and we don't have any business logic in this application, so we are going to skip a service layer. So if you have business logic in your application, then you can create one more package as service package, and you can keep all your business logic inside a service package. Alright, now our package structure is ready. Let's go ahead and let's quickly create an entity, JP entity. So right click on entity package, new, and then choose class, and let's give a class name as user. Alright, now let's quickly create a fields, private long ID, private string first name, private string last name, and then private string email. Alright, so these are the few fields. Let's go ahead and let's quickly create a getter setter methods to access these private fields. Alright, great. Now let's go ahead and let's also create a constructor. Right click source, generate constructor. I am going to skip ID because we are going to create ID by using auto increment. This is the class. Now we are going to make this class as a JP entity. For that, we are going to use JP annotations here. We are going to use entity annotation to make this class as a JP entity. Let's use add table annotation to provide a table details. So here we are going to give a name, table name as users. Alright, and let's define a primary key for our table. So we are going to use @id annotation, and let's define a primary key generation strategy. For that, we are going to use generated value annotation here. Inside that we are going to use strategy. Auto increment. Okay, and if you want to give a column name, then we can use add column annotation, and you can give a column name like this, first underscore name. Alright, here we actually specify name equal to like this, and let's copy this, and here let's give a column name for last name as well, last underscore name, and this is email. Alright, that's it. We have created user JPA entity, and this will be mapped to a relational database table, that is users, and these are the fields, and these are the columns which will map to these fields. Okay, great. Now let's go ahead and let's create a repository. Right click on repository package, new, and then create interface, and just give name as user a repository. Okay, great. Now let's go ahead and let's extend JPA repository, and just pass type as user and ID as long. Okay, great. Now let's annotate this interface with add repository annotation. Alright, so that Spring will automatically scan this as a Spring bin during component scanning. Now our repository is ready, so this will basically provide a CRUD database operations for user entity. Okay, great. Now let's go ahead and let's configure MySQL database. So under resource folder you can find application.properties file, and here we need to configure properties. For example, look at here, this is the JDBC URL for MySQL database, and this is our database name, that is users DB, and this is the username and password for MySQL database, and this is the Hibernate dilate for MySQL database, and this is the property we use to create database tables automatically during application startup. Alright, it's pretty simple application.properties. So once we configure MySQL database, then we need to create a database in a MySQL server. For that I'm going to use MySQL workbench. So this is MySQL workbench, and here I'm going to create a database. Create database, and name of the database is usersdb, and execute this statement, and you can see here database is created, usersdb. Alright, so what we have done, we have configured MySQL database in Spring Boot project, and then we have created a database in MySQL server. Now let's go ahead and let's create a custom exception. Right click on exception package, new, and then choose class, and here give a custom exception name as resource not found exception. So we use this custom exception in controller layer. So whenever we develop REST APIs, and if user not exist in a database, then REST API will throw this custom exception. Okay, that I'm gonna show you while creating REST APIs. So this exception should extend a runtime exception, and here we are going to annotate this class with @response status, and if resource not found, then we just return status as not found, right? For that I am going to just provide HTTP status as not found here. Okay, great. And here what we'll do, we'll create a constructor public resource not found, and then what we'll do, we'll pass a message here because we need to pass a message while throwing the exception. And here what we will do, I will use a super keyword to pass this message to the super class. Okay, great, that's it. And here we need to just create a serial version ID. Okay, so this is our custom exception. Alright, now what we'll do, we'll create a REST APIs. For that, go to the controller package and right click on it and new, and then choose class, and here give a name as user controller. Okay, and annotate this class with @REST controller annotation. So this annotation is a combination of @controller and @response body annotation, and we use this annotation to create a REST APIs. Alright, and we are using Spring MVC to develop this controller layer. Here what I will do is I will just first create a skeleton for our REST endpoints. So we are going to create all users, okay, get all users API, and then we'll create a get user by ID REST API, and then we'll create save user or create user REST API, and then we'll create update user REST API, and then we'll create delete user by ID. So these are the 5 REST APIs that we are going to develop. Now let's go ahead and let's use @request mapping annotation here and provide a path for all the REST APIs. So I'm going to give as /API/users. Now let's go ahead and let's auto-wire user repository. Okay, let's inject user repository using @auto-wire annotation. We are going to use all the CRUD database operation from user repository interface. Now let's go ahead and let's create a API, that is get all users API. So this will return a list of user objects, and I'm going to give a name as get all users. Okay, great. And here we just return user repository dot find all, right? So find all method returns a list of user objects, and let's annotate this method with get mapping annotation. Okay, great. This is straightforward API, nothing fancy here. Now let's go ahead and let's create get user by ID REST API. It's pretty simple, just create a method public user and give a name as get user by ID like this, and here we need to annotate this method with and get mapping annotation, and here we need to pass ID here like this. Okay, this is the path variable, and we are going to use path variable annotation here. Alright, and value equals ID. So look at here, this ID and this ID should match here, and this is type long, and this is the user ID. Okay, great. Now what we will do, we return a user object. Alright, for that I'm going to call user repository dot find by ID and pass user ID here. So basically this will return optional. Okay, so look at here, find by ID returns optional, and we need to call dot get method. Okay, and we are also going to throw the exception if user is not existing in a database for this ID. For that, what we'll do, we'll use or else throw a method, and here we just write the lambda expression, a new or resource not found exception, a resource not found exception, and here I'm going to just pass the message like user not found with ID. Here just give a user ID. Okay, that's it. Let me break this so that let's enter semicolon. Okay, that's it. So what we have done, we have just retrieved a user object by ID, and if user is not present in a database, then we throw the exception like resource not found exception. Pretty simple, right? Now let's go ahead and let's see how to create a post REST API. For that, what we'll do, we'll create a method again, public, and user, create user, and here what we'll do, we'll use @request body annotation. So this will map directly to the user object. So the JSON will directly map to the user object, and we are going to use @post mapping annotation. Okay, great. And here what we'll do, we'll just return this dot user repository and dot save method. So this will save user object into a database. It's pretty simple, right? Great. So now let us see how to develop put REST API, that is update user REST API. For that, I'm going to again create a method here, public user update user. Alright, and I annotate this with @put mapping annotation, and I'm going to pass here a path variable, that is ID. Okay, great. And then here I'm going to use again request body annotation. This is the user and user, and then I'm going to again use path variable annotation to bind a path variable to the type, that is long user ID. That's it. Alright, now let's update the existing user object. So first what we need to do is we need to get a user object from the database, and then we update it, and then we again save to the database. For that, what we will do, I am just going to copy this code, I am going to paste here. So this will return a user object, right? So I am going to get a user object. So this is the existing object. Okay, so this is the existing object from the database, and this is the new object that we are going to update. Existing dot set. So if you are going to update first name, then set the first name here, user dot get first name, and existing dot set last name, user dot get last name, and existing dot set email, and here I'm going to call user dot get email. Alright, so once you update the existing user object, then let's go ahead and let's save it. For that, call the save method here and pass existing object. Great, right? So what I will do, I'm going to just rename this. Okay, I'm going to call it as existing user, and here we are going to return this updated object to the client. That's it. Pretty simple, right? User update REST API. Alright, so next see how to delete the REST API. It's pretty simple. Again, what we need to do is we need to just create a method here, public response entity, and pass type as a user, and I'm going to call this method name as delete user. Okay, and let's annotate this method with @delete mapping annotation. And here what I will do, I will pass path variable again, ID. Pretty simple, right? And here we need to bind this ID. For that, I am going to use @path variable annotation, right? Just copy from here. Alright, it's pretty simple. Now what we'll do, so whenever we want to delete the user, then we first get the user from the database. For that I am going to just copy this code. So this will, this will find the user by ID. So I am going to first get existing user from the database, and I will simply delete this user. I am going to call user repository dot delete, and this is the existing user, so delete it. And then what we will do, I will just return here, return a response entity, and type not required here. I'm going to call OK, and then build. Okay, so this will return 200 response. It's pretty simple, right? So what we have done, we have retrieved existing user object by ID from the database, and we have deleted that object here by calling delete method. It's pretty simple REST APIs. So let me recap what we have done. We have created a user controller class, we have annotated it with @REST controller and @request mapping annotation, and we have injected user repository here, and this is the get all user REST API, and this is the get user by ID REST API, and this is the create user REST API, and this is the update user REST API, and this is the delete user REST API. So these are the 5 REST APIs we have built. Alright, now this completes our development. Let's go ahead and let's run our Spring Boot project. So go to the Spring Boot application. This is the main entry point of our project, and then right click and then choose run as Spring Boot app. So this will run Spring Boot project as a standalone in embedded Tomcat server. So look at here, embedded Tomcat server is running on port 8080. Alright, and we will test all the REST endpoints using Postman REST client. Alright, so if you don't know how to use Postman REST client, then I'm gonna show you. So this is the Postman REST client provided by Google, and this is the HTTP methods get, post, put, delete, and we are going to first test post method. So choose post here, and this is our URL. Okay, and this is the JSON request body, post name, last name, and email, and choose content type as application/JSON. And look at here, inside body we chosen raw, and then content type as application JSON. Okay, and this is the send button. So once we hit the send button, then this request will goes to post REST API, and post REST API will process this request. So let's go and let's hit send button. So look at here, we got a response. Alright, database actually record is created in a database, and that record is written by post API, and that record is we can see in a response here. Okay, with ID 1. Alright, let's go ahead and let's create a few more records. I am going to create post name Tony, last name Stark, Tony@gmail.com. Hit send button, and record is inserted in database, and same record is returned in a response with ID 2. Okay, great. Now let's go ahead and let's test the get REST API. Let's choose get HTTP method, and here we are going to provide ID as 1 and hit send button. Oops, we got an error. We have created user JPA entity, right? Oops, we got an error here. So we need to create a default constructor in user JPA entity. So here, look at here, we have created a parameterized constructor, right? But we haven't created a default constructor because Hibernate uses a proxy to create a object. So let's go ahead and let's use a default constructor here. Alright, now let's go ahead and let's rerun the application again. Right click, run as Spring Boot application. So now Spring Boot project is running on embedded Tomcat server. Now let's go ahead and let us test this get REST API. Now you can see here we have resolved the issue, and this is working fine now. So we got a response as user object with id 1. Okay, and if we pass id 2, then this will return a user object with id 2. Okay, so this is how the get API works. Now let us test put API. Okay, now we are going to update user 1. So I'm going to update username from Ramesh to Ram, and here I'm going to just provide Jadhav, and I'm going to provide a Ramesh. So let's go and let's send the request. So look at here, the user is updated successfully. Earlier the post name was Ramesh, and then it was updated with Ram. Similarly, last name and email. Okay, so this is how the put API works. Now let's go and let us test delete API. So we are going to delete this user with id 1. So let's hit send button. So user is deleted from the database. So let's go ahead and let's verify in a MySQL workbench. So look at here in a MySQL workbench, from the table first record is deleted. Alright, so what I will do, I will delete second record, hit send button, and second user is deleted and the response is 200. And let's refresh this. So look at here, second record is also deleted from the database. Let's go ahead and let's insert records, and then we'll test get all users REST API. Okay, so this record is inserted. Again, let's insert one more record, Ramesh Pardare, and change email as Ramesh. Let's hit send button. So this will create a record 4, and then again insert one more record, Tony Stark, and then tony@gmail.com. hit send button. This will create a record 5. Okay, let's verify in MySQL workbench. So look at here, 3 records are created. Alright, now let's go and let's use a get all users API. So look at here, we got a response as array of objects. Alright, so this is how we basically test all the 5 REST APIs using Postman REST client. Now let us test the negative scenario, like whenever resource not found in database, then we need to send a proper response to the client, right? So for example, let us say if record with id 8 is not exist, then I'm going to hit the send button. So look at here the response. If user with id 8 is not present in database, then we got this response. And this is created by Spring Boot, and we can customize this exception handling as per our need. But this looks good, and this is the default exception handling provided by Spring Boot. Alright, great. Alright, we have successfully created CRUD REST APIs using Spring Boot, and we have tested all Spring Boot CRUD REST APIs using Postman client. Now we are going to host a source code of our Spring Boot application on GitHub. So just log into your GitHub profile and create a GitHub repository with the name Spring Boot CRUD RESTful Web Services. Okay, just create a GitHub repository with the name Spring Boot CRUD RESTful Web Services. So I have already created GitHub repository on my GitHub profile, and I have already hosted a source code. So we're gonna use Amazon Relational Database Service to set up our MySQL database on AWS Cloud. Okay, so Amazon Relational Database Service makes it easy to set up, operate, and scale a relational database in the cloud. Alright, and here are the Amazon RDS database engines, and we're gonna focus on MySQL database. Okay, so we'll set up MySQL database on AWS Cloud using Amazon Relational Database Service. Okay, great. So look at here the workflow. So far we have created Spring Boot application and deployed on locally, and our Spring Boot application has connected with MySQL database, which is configured on local machine. Okay, Now in this video, what we're gonna do is we're gonna deploy our Spring Boot application on AWS Cloud, and we'll also deploy MySQL database on AWS Cloud using AWS RDS service, and we'll connect our Spring Boot application which is deployed on AWS with MySQL deployed on AWS Cloud. Okay, great. So let's take a look into the development process. First, we're gonna log into AWS console using AWS console credentials, and then we'll set up MySQL database in AWS Cloud using AWS RDS service, and then we'll connect our MySQL database that we have set up in AWS Cloud using RDS with MySQL Workbench to verify the connectivity. So once we set up MySQL database in AWS Cloud using AWS RDS, then we'll connect this MySQL database with our local MySQL Workbench just to verify the connectivity. And then what we're going to do is we're going to clone Spring Boot application source code from the GitHub repository, and then we'll update application.properties file just to change the database MySQL URL property. Okay, so we have set up MySQL database in AWS Cloud, right? And this AWS Cloud MySQL database URL we need to configure in application.properties file. Once we configure everything, then we package our Spring Boot application as a jar file, and then we'll deploy our Spring Boot jar file on AWS using Elastic Beanstalk service. Alright, once we complete Spring Boot application deployment on AWS Cloud, then we're gonna test the REST endpoints using Postman client. It's a pretty simple, guys. Just we need to follow the steps. First step is we need to log into AWS console. So we're gonna use AWS pre-developer account to deploy Spring Boot applications on AWS Cloud. So I have already created a couple of videos on deploying Spring Boot applications on AWS Cloud. So to understand the basics, you can go ahead and you can check out my previous AWS deployment videos. So let's head over to the browser and let's log into AWS console. In a new tab, just type awsamazon.com, hit enter, and this will bring you the home page of Amazon console. And if you haven't created an account, that is AWS free developer account yet, then you can go ahead and you can create an account. Okay, I have already created AWS free developer account, so I can go ahead and log into the AWS console. Alright, if you haven't created an AWS account yet, then you can go ahead and you can click on create new AWS account here. Alright, and this is a free tier product with a new developer account, so you can go ahead and provide all the details. And this is the first page. In a second step or second page, it will ask you to provide credit card details and other stuff. So you can go ahead and you can enter all the details, and you need to sign up to this AWS account. Alright, once you successfully sign up, then you can come back to sign in page and just enter your email ID. Just type the characters here in order to do the security check. Alright, and then enter the password. And there we go. So this is the Amazon management console page. Okay, now we have successfully logged into AWS management console. Now the second step is we need to set up MySQL database in AWS Cloud using AWS RDS service. So let's go ahead and let's select AWS RDS service. So just scroll down and go to the database section here and just click on RDS. Alright, now what we're gonna do is we're gonna create a database. So let's go and let's click on create database here. Alright, and choose standard create. So let's keep standard create as a default as it is, and here we're gonna choose MySQL database engine. Okay, so look at here the steps. We need to choose a database creation method and then engine option. Let's choose MySQL database here. Alright, and version keep default, that is 8.0.20 as it is. And look at here, this is important. Choose free tier. Okay, choose free tier, don't choose production. Okay, this will charge you, so you need to pay for this option. So just select free tier so that we can, this is for just for learning purpose. You can go ahead and you can choose free tier here. And after that we need to create a DB instance. Well, let's go ahead and let's give instance name here. Just give Java guides. I will give Java guides, you can give any name that you want. And then here we need to provide a username and password for this DB instance. So I am giving the username as a root and password as a password, confirmation password. Alright, now let's keep this default DB instance class, that is db.t2.micro, and then storage keep everything default, and in connectivity just keep default these fields as it is. And here is the important field, that is public access. Say yes. Alright, and then go ahead and just click on additional configuration here. So let's keep this database port as it is because this is a default port for MySQL database server, and go ahead and click on additional configuration here. And here we need to provide the database name. Okay, so we can also create a database later on once we connect this MySQL database from our local MySQL workbench. Okay, so you have two options: either you can create a database directly from here, or you can create a database while connecting to this MySQL server from the MySQL workbench. Alright, and let's keep everything default. Okay, and say create database. Alright, if you look at the status here, so this is creating. Well, AWS will basically take several minutes to launch this DB instance, so let's wait a couple of minutes to bring this status as available, and then we can proceed accordingly. Alright, so this will take a couple of minutes to launch the MySQL DB instance. So meanwhile what we're gonna do is we're gonna clone the source code of this project from my GitHub repository. Alright, go to the file system and just open a git bash here. So you can use a git to clone the GitHub repository, or you can simply go ahead and you can download this GitHub repository as a zip file here. Okay, I have already installed a git on my system, so I can use git to clone this GitHub repository. Alright, so just type the command git clone and just copy this URL and paste it here and just hit enter. Alright, we have successfully cloned this GitHub repository from GitHub. Alright, so if you can check out the application.properties file, just right click and edit with Notepad++, and look at here, we have configured MySQL local server URL here, localhost, and then followed by 3306 and name of the database. and this is username and password, and this is MySQL Hibernate Dilate. Okay, and this is a property to create tables automatically and update the tables automatically. All right, now let's go back to the AWS console and let's see the status. It is backing up. Okay, let's wait a couple of more minutes to change this status to available, and there we go. The status is available and successfully created database Java guides. Okay, great. Now look at here, this is the DB identifier, so go ahead and click on this. Alright, and if you look at the connectivity and security section here, this is the endpoint URL, and this is the port, database port, and this is the security section, and this is the networking. Now what we're gonna do is we're gonna change the security up for this database. Okay, so go ahead and click on this default link here. So basically we need to provide a security to access this database from anywhere. So for that, let's go ahead and let's change the security here. Okay, just go ahead and click on this security group ID here. All right, now just click on edit inbound rules. Now let's go and let's add a rule here. Just choose MySQL Aurora here, and then the source we need to change here, just change from custom to anywhere. So we need to access this database from anywhere, so let's choose anywhere here, and that's it, and click on save rules. Alright, so inbound security group rule is successfully applied. Now let's go back to our database instance. Alright, we have successfully configured MySQL database on Amazon AWS cloud using RDS service. So next step is we need to connect MySQL database with MySQL Workbench to verify the connectivity. Let's head over to the MySQL Workbench and let's make a connection from MySQL Workbench to this MySQL database that we have just configured in AWS cloud using AWS RDS service. So go to the MySQL Workbench like this, and so look at here MySQL connections. So this is a plus icon. Go ahead and click on this plus icon here, and this will bring you the pop-up screen, and here we need to just enter the details. Connection name, just provide Java guides. Okay, Java guides on AWS, something like this, and here host name. So let's give a host name as endpoint URL. So let me show you how to get the host name from the AWS cloud. So look at here, this is the Java guides DB instance, right? And if you go to the connectivity and security section, here we have endpoint and port. So you need to copy this endpoint. So this is the endpoint or host for this database. Just copy and paste in a host name section, and we have provided username for database as a root and password as a password, and just click on test connection. Here we go, successfully made the MySQL connection. That's awesome, right? We have successfully made a connection from MySQL Workbench to MySQL database on AWS cloud. Alright, click on OK and click on OK here also, and here we go. So go ahead and click on this connection here. Alright, we have successfully made a connection from MySQL Workbench to MySQL database on AWS cloud. Let's take a look into the next step. So next step is we need to clone Spring Boot application source code from GitHub. So we have already completed this step. So next step is we need to update application.properties file to just change the JDBC MySQL URL property. Alright, we have configured MySQL database on AWS cloud using AWS RDS, right? Now you're gonna simply replace a localhost MySQL database URL with a MySQL database which is configured on AWS Cloud. So just go ahead and copy this endpoint or host name and go to the application.properties file of our Spring Boot application. So look at here, this is the JDBC URL, right? JDBC MySQL URL, and earlier it was pointing to localhost MySQL database. Now let's go and let's replace from localhost to this host name. Okay, so this is the MySQL database URL which was hosted on AWS Cloud. Alright, that's it. Now let's go and let's create users DB database inside MySQL database. So let's go ahead and let's head over to the MySQL workbench, and here just write the query create database followed by name of the database and execute the query here, and just go ahead and refresh the schemas, and there we go, we have successfully created users DB. Okay, and this database is created on Amazon Cloud because we have successfully made a connection to MySQL DB instance on Amazon Cloud, right? Now we have created users DB database. Let's take a look into the next step. Alright, so next step is we need to package our Spring Boot application as a jar file, and then we'll deploy this Spring Boot jar file on AWS using Elastic Beanstalk service. So go back to the application.properties file again, and what we're going to do is we're going to change the Spring Boot application server port. So by default Spring Boot application listen a port 8080, right? That is embedded Tomcat server port, but Elastic Beanstalk service expect Spring Boot application to listen a port 5000. So let's go ahead and let's just change the port number here, server dot port. So this is the property to change the default port. So let's go ahead and let's give port number as 5000. Okay, now go to the file system, and we need to package our Spring Boot application as a jar file. So let's click here and just type cmd. So this will bring a cmd inside this folder, and just go ahead and just type Maven. So make sure that you have installed Maven on your machine. Just type Maven clean install and hit enter. So this will make a Maven build for this Spring Boot application. Let's wait a couple of seconds. So look at here, the build is failed because we have provided a wrong database password. So let's go back to application.properties file, and look at here, we haven't changed the password here. So we have provided username as a root and password as a password, right? So this is important, guys. So whenever you configure MySQL database on Amazon Cloud, you need to replace the host here and then username and password. Okay, now let's go back to the command prompt, and here let's again enter the command maven clean install. Alright, the Maven build is success, and go to the MySQL workbench and just refresh the schemas here, and look at here, the users table is also created. Okay, now go to the file system again and go to the target folder, and this is the Spring Boot jar file. Now what we're gonna do is we're gonna deploy this Spring Boot application jar file in AWS Cloud using Elastic Beanstalk service. So we have successfully packaged Spring Boot application as a jar file. Now we're going to deploy this Spring Boot jar file on AWS using Elastic Beanstalk service. So let's head over to again Amazon website and go to the services, and in a compute section click on Elastic Beanstalk. So if you are new to Elastic Beanstalk service, then you can watch my previous AWS deployment videos where I have shown you step by step how the Elastic Beanstalk service works and how to deploy step-by-step Spring Boot application on Elastic Beanstalk service. Alright, now go ahead and click on create application button here, and here we're going to provide application name, for example Spring Boot, MySQL, and MySQL CRUD AWS, okay, something like this. And after that you can also provide application tags here to just group and filter your resources. And here in a platform section, just choose a Java. So because we have packaged our Spring Boot application as jar file, right, and we're going to run our jar file using Java command. So for that we're going to choose a Java here and keep platform branch as it is, and platform version keep this recommended one, and just go ahead and click on upload your code here and keep version label as it is. So this is a default name provided by AWS, and click on choose file. Alright, and just go to the folder where your jar file is created, go to the project, go to target folder, and here we go. So this is the Spring Boot jar file, so select it and hit open, and this will upload this Spring Boot jar file in S3 server. Okay, basically Elastic Beanstalk service, it will provide all the resources that we require to deploy our Spring Boot application. So behind the scene, it will create a EC2 instance for us, it will create S3 server, and it will upload this jar file in a S3 server. Okay, alright, and go ahead and click on configure more options here, and go to the database section here and click on edit, and here we need to provide a username and password. So we have provided username as a root and password as password, and that's it. Click on save, and go ahead and click on create app. So basically Elastic Beanstalk service will create an environment to deploy this Spring Boot application. So look at here, Elastic Beanstalk service first create EC2 instance, and then it will create Amazon S3 server storage bucket for storing our Spring Boot jar file in it. Let's wait a couple of minutes, it will take a couple of minutes to create this environment. Alright, so look at here, our application successfully deployed and health is okay. Now let's go ahead and let's click on this link here, and there we go, our Spring Boot application successfully deployed. And just type here API/users to list out all the users. So we haven't created any user in a database, so that's why this REST point returns IMT array. Now we have successfully deployed our Spring Boot application on AWS cloud. Now what we're going to do is we're going to test CRUD REST APIs using Postman client. So let's head over to the Postman client and let's test all CRUD REST APIs. So if you go to the Spring Boot project on GitHub, that is Spring Boot CRUD RESTful Web Services project, just go to the main, go to the controller here, and this is the user controller class, and look at here, this user controller class exposes CRUD REST APIs like get all users, get user by ID, create user, update user, and delete user. So we're going to test all these REST APIs, and this is the REST point base URL for these REST APIs. Okay, great. So let's head over to the Postman client, and before that let me just copy this URL, and in a Postman client create a new request, and Here just choose a get HTTP method here and just enter the URL just we have copied from the browser and hit send button, and here we go. Okay, nothing is there in a database. Now what we're gonna do is we're gonna insert few records. For that, let's choose HTTP post method here and go to the body and go to the raw and choose content type as JSON here and just create a JSON object quickly here. So look at here, our entity has fields first name, last name and email. Okay, just give first name here, let's say Ramesh, and last name Padatare, and then email ramesh@gmail.com. Alright, now let's go ahead and let's click on send button, and there we go. We have successfully inserted a record in a database and REST API returned this response. Now let's head over to the MySQL workbench and let's verify this record in a database. So just go to the users database, that is users DB, and this is the users table. Right click on it and say select rows, and there we go. A user is inserted in a database. Okay, now let's test other REST APIs. So let's go and let's test get user by ID REST API. So we just pass the ID 1 here to get this user by ID 1 and hit send button, and here we go. We got user 1 in a response. Okay, now what we're gonna do is we're gonna update this user. So just choose HTTP method put here and change post name from Ramesh to Ram and change email as well. Okay, and hit the send button here, and there we go. Post name and email successfully updated. So look at here the response. Okay, and if you check the database, just execute this query, select query, and you can able to see here the email and post name is updated. Now let's go ahead and let's test delete user HTTP. Click on delete HTTP method and hit send button, and there we go. Okay, so we have successfully deleted a user, and this REST API returned 200 okay as a response code. Now let's verify in a database. Let's go ahead and let's execute this statement, and there we go. The record is deleted from the database. Alright guys, we have successfully deployed our Spring Boot MySQL REST API code application on AWS Cloud, and we have tested all the REST endpoint URLs using Postman client.